Hi everyone, so welcome to the first real technical video where we'll actually start producing some images in Stable Diffusion. So in this video we're going to go over just some basic generation. We'll start just producing an image in a square aspect ratio. Then we'll go into learning about the different parameters, different checkpoint models that we can modify and change to achieve different stylistic or like higher or lower resolution results. We'll change the sampling steps, the CFG scale. We'll play with complex and more simplistic prompts and use AI as a way to generate prompts and really descriptive language. That's really good for Stable Diffusion. And then we'll produce different variations, playing with all those different variables, tweaking all those different parameters. And at the end, you'll have created at least this many images in the matter of about 20 minutes. This video does not deal with ControlNet, so this is just text to image. We're not adhering to any predefined shape or anything like that. It's just text to image. So let's get going. So we're just going to start here by opening up the Stable Diffusion web UI. So in this video, I'm going to show you how to just start with a basic image generation using a text prompt. Next, we'll move into talking about the different parameters that we can adjust to change the quality and sort of creativity of our images. Then we'll go into using different checkpoint models and look at the different aesthetics that they produce, the different styles they produce. We'll change the things like the sampling steps, the CFG scale. We'll start to build a more complex prompt and use a GPT to assist with that. And then at the end, we'll just kind of play around with different variations by tweaking the parameters. So let's get started. So this is our interface, and you can see here we're on the text to image tab. There's multiple other tabs allowing you to do different things. And let's get started just by entering a prompt here. Let's say modern basketball arena exterior rendering. What material do we want? We want glass, concrete, and steel. Let's say overcast sky, evening light, urban context. And let's just hit generate, see what happens. So notice here that we're working with the Juggernaut XL checkpoint model. This drop-down menu up here is where we can choose different checkpoint models. These are the 3 that came preloaded with the installation that I gave you. Okay, so here's our image using Juggernaut XL. Let's see what Architecture Real Mix looks like. Using the exact same prompt here. Okay, much different look to it. We've got some people here, reflecting pool, kind of a city, looks like kind of a retail context. And let's look at this ArcViz model. It takes a while for it to switch over to a new model, but then it will generate right there. Okay, so real ArcViz, I have to say I like this one the most. Interesting, so that's how we do a basic generation. Now let's get more into these generation parameters here. So down here is where you'll be able to tweak all the generation parameters for the text to image feature. Starting with the sampling method, dpm++2m. So I never change this. I'm sure these produce slightly different results. You feel free to play with them, but I usually just leave it at the default. Same with the schedule type. I've seen people use Keras, but I always use automatic. Sampling steps. So this is This is basically like the sophistication, the level of detail of the image that you're going to produce. A lower sampling step will produce images more quickly, but they'll be sort of lower resolution, lower detail. 20 is a really good draft amount, so it gives you enough detail to decide, okay, is my prompt good enough? Do I need to tweak some of the other parameters, or is it kind of satisfactory and I can start to turn this up to achieve more detailed results? Or you can quickly, when it's low, you can quickly realize, oh, okay, so I need to add more detail to my prompt to achieve a better image. So let's increase this to 50. When you're at 20 is a good balance of speed and detail. 50 is more of a final production quality. So it'll take a little bit longer. Okay, great. Some of these shadows here are a little weird. I'm not sure if that's because my sampling steps are much higher or what. So let's try lowering it to 40. See what happens there. Okay, interesting. So we're going to start changing some of these other parameters and produce a lot of images. So I'm going to decrease this to 20 for that faster operation. Okay, so next we've got the high-res fix. What this is a built-in image upscaler. So you'll notice down here we can define the size of the image that we want to produce in pixels. Right now we're producing 512 by 512 in a square. If we turn on the high-res fix and hit generate, this will upscale the image by the factor that we enter into this field. So if we produce a 512 by 512, check the high-res fix, upscale by 2x, we'll end up with an image that's 1024 by 1024 pixels. There are also ways to do this after you've produced the images at a lower resolution. So you can produce images really quickly and then bring them into this other extras tab where you can use a non-integrated upscaler. So we're not going to worry about this right now. We're just going to produce a lot of images with a lot of variety to kind of explore the space and get a sense for what these checkpoint models do. The refiner. I never touched the refiner. I haven't seen any tutorials on it. I haven't learned much about it, so we're going to skip that for now. So let's change our image dimensions to 960 by 540. That's half of the 1920 by 1080, 16 by 9 aspect ratio. Let's leave the batch count at 1. Batch count is the number of times that we want this process to run when we hit generate. We are going to modify the batch size. So that means if I hit generate with a batch count of 1 and a batch size of 4, we're going to get 4 different images, 4 distinct images in one generation. Now, if I leave this at 4 and turns the batch count up to 2, we're going to get 4 times 2, 8 images, because we're going to generate 4 images in the first batch, 4 images in the second batch. Oops. Okay, I'm going to close this refiner. Okay, so that's good. Next, we have this CFG scale. So CFG scale is basically the level of creativity that we're allowing the diffusion process to have, the AI to have. So if it's a high value, and typically I think a high value is like 9 to 11-ish. If you get over that, roughly, if you go any higher than that, you start to lose image quality. It starts to look a little overcooked and weird. So on the other side of that scale, if you have a CFG of 1 or 2 or 3, you're starting to be very loose. Maybe the image that you produce doesn't really adhere to your text prompt as much, but it's a good creative tool to start kind of exploring what's possible by using this, using stable diffusion. And you might get some really exciting, unexpected results. So for now, because we're early on in this, let's set our CFG scale to 2, so really low, and We turned up our batch size to 4. We've adjusted our image size, and we've reduced the sampling steps back down to 20 to get really quick results. So let's go ahead and run that. Okay, great. We've got 4 distinct images here. Very interesting. All very distinct geometries, formal expressions. So, and all with the materiality and context and lighting that we defined. So let's just go in here and add a note that we want architectural rendering, perspective rendering. Let's add that in. Let's say that we don't want people or cars. And let's try to run that again. So with these generations, one thing I didn't mention earlier is this seed variable. So the seed requires a little bit more detailed explanation. So the way the diffusion model works is you give it all these parameters, you give it a prompt, you choose a checkpoint model, all of this, and then the first thing that it does in the generation process is produce an image of complete noise, like static. So an image where every pixel is kind of a random color. Next, through the diffusion process, it starts to imagine and like paint in sort of these objects and characteristics that we've defined from that noise. So what the seed value does is defines the initial noise that we start with. If we give it a random seed, every image will start from a completely different initial noise image, and then the results will be different. So it might imagine the building in a cubic shape versus in a cylindrical shape or something. However, when we generate with a random seed, we can see the parameters that were used to generate each image over here. These are all different seed values. And what we can do if we like a certain one, I like this image, I think it's great. So I'm going to take this seed here. I'm going to replace the -1, which indicates a random seed. I'm going to paste it in there. And you'll notice if I go and hit the dice again, I'm rolling the dice, I'm going to get a random seed, it's going to be -1, and then each image is going to have a different initial noise value. So I'm going to paste this one in because I want to try to get more images that look like this. I like this roof thing, I like the perspective that we have, I like the sky. So I'm going to put that seed there. And then I want a slightly higher resolution image to see if I'm on the right track. So I'm going to go in and put 40 in here, and I'm going to leave it with the ArcViz. So let's see what happens now. Okay, so we've got 4 different images now, and let's see what we've got. So that's basically the same image that we had before. This is a much different perspective. This one's also quite different. Oh, that's interesting. Okay, and so it looks like our negative prompts aren't working too well. We're still getting people and cars in these images. So what I'm going to do, I want a little more adherence to my prompt. I'm going to increase this CFG scale to 7. I'm going to leave the seed where it is and leave the rest where it is. And let's see if we get a little bit more similarity between images and a little more adherence to our prompts. Okay, 4 new images. Let's go. Sky looks great. We've still got the concrete, glass, and steel facade. Yeah, wow. And a lot of formal variation between all of these. Great. Got a nice level of detail. And so just to experiment with this a bit more, I'm going to run through each one of these checkpoints and kind of explore the stylistic differences, the kind of images that these different checkpoint models are inclined to make. So I'm just going to hit generate. If I'm going to leave all the parameters the same, I'm going to hit generate a few more times. We're switching from the real arc viz to the architecture real mix. We're going to see what happens. Okay, so here's the results from the architecture real mix checkpoint. Still got a good amount of variation. The perspective is pretty consistent. And the lighting condition is the same. One thing you'll notice with the architecture real mix checkpoint is that its tendency to produce a lot of vertical lines in facades. It loves mullions, and it loves this kind of yellowish, warm light. So there are certain limitations based on the checkpoint that you're using to produce stylistic effects. However, in future videos, we'll get into looking at LoRa models and how those can really work to influence the effect. So that's architecture real mix. Let's look at Juggernaut XL. Now, Juggernaut, unlike these other two, is trained more generally on more of the object world. So less of a focus on architecture exactly, and more of a focus on just a wide variety of things. And you'll notice that the size of this checkpoint model, the safe tensors file, is significantly larger. Let's run that. So I'll just mention as this image finishes up that the SD VE, the Stable Diffusion VE, this is a variational autoencoder. It is a model that is used sort of in the final steps of image generation to smooth out anomalies and just contribute to a higher resolution, a better image in the end. So I also included two of these in the final. Not in the folder that you all downloaded. So there's an XL model and another model here. Okay. So here are the Juggernaut results. Interesting. These look a little bit overcooked or something. They look a little bizarre. The resolution doesn't look great. So I'm going to lower the CFG scale. I'm going to go down to 4 and see if that does anything. Remember, like I said before, if the CFG scale is a little bit too high, the images can start to look a little bit overcooked, a little weird. Excuse me. So we'll see if that has any effect. Okay, 4 new images. Yeah, so these are looking better. They look more or less formally the same. Got the same seed value in there, and the resolution on these is just so much better. They look less cooked, just a better image overall. So what we can do to get a little bit more control over the image that we're producing and start to dial in what we want to produce is just work on our prompt a little bit. And one thing that I've been doing is using an AI agent to help with that. So I've been using Claude. You can use GPT, any of like chat any of your preferred GPTs. And what I like to do is just find images online that have the same maybe materiality, building type, lighting condition, context, mixture of all those things, or all of them together, that I want to try to replicate or get good descriptive language of. And maybe you're already really good at this on your own. You don't need the assistance of an AI agent. That's great. But I think this is a good place to get started. You get a lot of good descriptive language, and then you can go in and modify things from there. So I'll just say, give me a stable diffusion prompt to generate images like this for a modern basketball arena architectural rendering. It'll think about it, and then it will give me something I can copy and paste. Oops. Copy, paste in there. And I will leave people and cars in there. It seems to be doing its job now that I've increased the CFG scale a little bit. So let's go ahead and run that. So if you'll notice now, the prompt is still a modern basketball arena architectural rendering, but we're specifying the facade. We're specifying that we want a cantilevered upper level, translucent polycarbonate panels, glowing interior lighting, blue hour sky gradient. And it looks like our image is going to be really blue and purple. Clean geometric lines, empty plaza foreground, architectural visualization. It's referencing some studios, some firms, and here's a description of the image quality. So context and image quality here. 8K resolution, high detail rendering. And it seems that Juggernaut always takes a little longer than the other checkpoint models. Okay, here are the 4 results. Very interesting. There's not much about these that is saying basketball, but I could see how maybe in the middle of this one, you could have a basketball court there. So let's see how this will look with the real ArcViz checkpoint model. And let's go in and change this. Let's remove this. I think this is causing the building to look blue like this. Let's change it from an empty plaza foreground to a, let's call it city street corner context, street corner foreground, ArcViz photorealistic render, cantilevered upper level. Okay, let's see what this is going to look like with the real ArcViz. Okay, great. Very interesting. So let's try to re-randomize our seed here and change this from a glass facade to a concrete facade building. With glowing interior light, and let's change this to afternoon lighting. Give it a little bit more freedom on the CFG scale and generate. Okay, great. I've got a little more concrete in there. We still have some more people, so it's looking good. I am going to change this back to Juggernaut, and I'm gonna delete that. And I'm gonna delete the polycarbonate, see if I can get rid of all this glass. CFG scale back to 5, random seed. Okay, that's bizarre. But yeah, there we have it. There's some interesting results. So that's about it for the text-to-image tutorial. A lot of just tweaking parameters. The intent of this video is really just to show you how, by changing the CFG scale, seed, sampling steps, batch size, and image size, and by modifying the prompt, you can start to produce some images in Stable Diffusion. One thing that I would like to mention here is that all of the images that we produce using the automatic A1111 interface are automatically stored. So while you can download them here in the interface, they also go to that enhanced base folder under outputs, and so they're classified as image-to-image images, basically by the way that you produce them. So text-to-image grids, these will be the 4 images that you produce together, all saved together, and then text-to-image like as individual images. So if I go in here, go to today's date, I can see all the images that we just produced. So that's a helpful note. So that's it for this video. In future videos, we'll talk about image-to-image, image upscaling, using LoRa models, creating LoRa models, and then using in-paint anything to modify certain portions of an image. All right, thanks.